we should be recording. Um, so yeah, we're just going to get straight into the event. It's going to be one quick behavioral question that I'm going to ask our engineer, and then we are going to do a technical interview. So he's going to ask me a question, and then we're going to flip-flop again, where he answers the question that he asked me, but in a better and more efficient manner. So yeah, without further ado, let's get started. I guess, engineer, do you want to introduce yourself real quickly to everyone?
Yeah, hold on. I'll turn on my cam too. No, one sec. All right, hey guys. Actually, y'all should put on your camera. Otherwise, it's like less intimate, you know. Right? Yeah, you want the most out of the situation at least. But hello there, hello. There's not too many people, so I'm like, we could just turn this into just like a chill hangout, you know. But anyway, what's up, guys? I don't want to put my name out there, so I'm just an engineer. I work at Google. I guess I'm like a mid-level engineer, something like that. So I'm a bit old, and I work on systems. So I'm building out this thing called Borg, which is like, if you guys heard of Kubernetes, it's the thing that Kubernetes was based on. We basically power all of Google. We're the reason it runs. And yeah, I write C++. I don't know if there's much else in terms of my work, but I studied in university computer science, and then now I'm off doing my master's. So cool. So I think Eddie met me at a prior session that I did where I was giving a similar thing for a different community. It was much bigger. Hopefully that one went well. Sounds like, for him to invite me back. But I'm trying to switch it up where I feel like the last one we did was like, we did a tech interview, mock interview thing. I think that was chill, but I felt like most people didn't understand what I was saying because there's students and I'm kind of more like in the industry. So maybe trying to shift it more towards just like whatever you guys want to get out of it. So yeah, hopefully the mock interview thing is short and you guys can just ask whatever questions you want or have about interviews or tech or whatever it is. So cool. You want to just get into it?
Yeah, awesome, sure. So I guess I'll take the role of the interviewer. Again, this is going to be the behavioral portion. So hey, engineer, my name's Eddie. I am currently the president of Developer Student Clubs, which is a pretty cool initiative where we invite speakers to hold technical workshops, and we build projects to solve problems in our local community. Why don't you tell me a bit about yourself?
Yeah, sure.
As an intern.
I'm an intern. So my name's Ryan. It's not actually Ryan. So let's say I'm an intern. Let's say I interned at like Facebook, okay? And my name's Ryan. Okay. All right. So hi Eddie. My name's Ryan. I'm a sophomore at University of Florida. I just completed my internship at Facebook last summer. I was on the security team working on a pretty large invariant detector system where we were essentially trying to use requests at Facebook as the training, and what we're trying to learn is whether or not certain request patterns are anomalous and try to block them. So it's kind of like a interesting way to enforce security policies, an automated way to basically build security policies. And I had the pleasure of helping build that out for the new framework that they were implementing for all developers. And pretty good summer. Let's see. I am particularly interested in systems development, so I like writing C++ code. I honestly just like writing code that's closer to the machine itself. So yeah.
Yeah, that sounds awesome, Ryan. I guess, is there anything else you want to expand on? It sounds like you had a great summer. Maybe one of the more recent or interesting problems or projects that you had the chance to work on, either at school or at Facebook.
Yeah, that sounds good. Maybe I could talk about at my internship at Google in the prior
High
summer.
school?
No, wait. Yeah, that would be high school. Yeah, so I was the first high school intern that they ever had. And I worked on the database team. So I was on Spanner. And one of the projects that I worked on was essentially re-architecting a protocol that they had for MVCC, which is like the concurrency control mechanism. And I essentially made a new protocol that, so I guess to give a bit of context, not to dive too deep, is what they had before was a way for them to implement multiple revisions in the database and essentially having multiple copies of data so that concurrent access is faster. And they would do that by, with all their multiple nodes, what they would do is like they would grab a distributed lock, like from Zookeeper, and use that to essentially claim exclusive access. And that's how they would label their data, so that you can label it monotonically. And the problem is now that you're using this central lock, even though it's reliable in the sense that it's distributed, but it's also still one single point of failure, and also is a bottleneck in terms of performance. As they were adding more nodes, they were running into an issue where the latency of just getting a number for labeling the data would take minutes. And for a database that's claiming to give milliseconds freshness or seconds freshness, it doesn't work out. And so I contemplated some other options, realized it's an unsolvable computer science problem, and then realized that we don't actually need to solve this problem. And I reworded the problem from, let's not actually get monotonically increasing numbers, and let's get numbers that are eventually monotonically increasing. And so I based my algorithm based on how stream processing does watermarks. And it's pretty much a copycat, and it worked pretty well. It ended up reducing latency by 99%. And yeah, it was a pretty good project, I'd say.
Amazing for a high school student.
Yeah.
Yeah. I guess, yeah, is there anything you want to, like going outside of the interview now, is there anything that you want to tell, the audience about the behavioral portion?
Oh yeah, sure. So behavioral, honestly, I remember Eddie and I talked about this before this call. I feel like behavioral is not as important because, like, it's important in that you don't want to screw that up, but it's not going to be as important as actually doing your like coding question correctly or your resume. It definitely is a good plus to have. And I will say, like, your goal for the behavioral interview and also the coding portion really should be to like connect with your interviewer, and you want to get to the point where the interviewer will feel bad about rejecting you. So I have a lot of friends that interview, right? And they always feel bad. It's like, I don't want to reject this candidate because they're so nice, or like I like talking to them. You want to get to that point where then they're a little iffy. Let's say you didn't do too well. They might actually say, oh, okay, well, I think they were just really good. Maybe it wasn't their best day. They might actually tip you over and give it another shot, like another interviewer. I remember when I was a sophomore, that actually helped me out once. I screwed up my first interview. I interned at Facebook, and my first interview, I just screwed it up. And I thought I connected pretty well with the interviewer though. And somehow I got a second interview. I didn't even answer the question properly. So yeah, I figured it was just like likability. And now that I'm in industry and I see my friends interviewing, I get a feeling there's a bit of that where like you'll get a second shot if you're like a chill person. So yeah, just don't be too nervous. Like, just imagine it's just another human across the screen, and they're just looking for their next coworker. So just try to be chill, not too uptight. Don't show off too much. Show off, but like don't be obnoxious about it. So yeah, that's just my tips for that.
Yeah, awesome. Cool. Then do you want to get into the technical question?
Yep, let's do that. Do you want to share your screen?
Yeah, I'll share my screen. Let's see. Okay. Can you all see this?
Should I just look at your screen?
Yeah, that probably works better.
Sounds good.
Cool. Yeah. So now we're going to swap roles. Ryan's going to be the interviewer, and he's going to ask me, the question.
Cool. All right. I'll just call you Eddie. All right, Eddie. So let's move on to a coding question now. So I have this question here. I'll just paste it in for you to read, and let me know if you have any other questions.
Yeah, sure. So given a 2D board and a list of words from a dictionary, find all the words in the board. Each word must be constructed from letters of sequentially adjacent cells, where adjacent is horizontally or vertically neighboring. The same letter may not be used in Okay, cool. So first off, I guess I just want to clarify the problem real quickly. So let's say that I'm given, okay, so this is my input board and this is my list of words. Let's say I want to look at oath. Um, Adjacent means like starting with this O, either I guess up, down, left, or right on the board, not like diagonally.
Yep.
Okay, cool. And um, are all of the, like is my input, are all of the letters going to be lowercase or
Yeah,
capital
you can assume
or
that. Mm-hmm.
lowercase works? Okay, cool. Um, yeah, I think that's all oh, I guess are all of the words in my like array of words distinct, or are there repeats that I have to account for?
Yeah, there could be repeats.
There could be repeats. Okay. Okay, that's fine. Uh, cool. So my first thought is to really to use a trie or like a prefix tree, because I know like those are really good for solving these kinds of problems where you have to like manipulate like words in like a graph situation. But unfortunately, I don't really know that data structure too well, so I'm going to come up with a different solution. But I think that might be a more efficient way of doing this. But for now, I'm going to treat this as like a graph. So this is basically an adjacency matrix, and each one of these letters can represent a node. Um, and yeah, I'm going to simplify the problem a bit more by first dealing with just a single word. And then I can like iterate through this list of words to, run the same algorithm like d times, where d is the length of the list. So let's see. So if I take my word oath, the way that I would normally do a word search, or the way that I used to do word searches in like elementary school, is I would take the first letter of the word I want to look for and then scan my like, my crossword puzzle, or yeah, my like board for that letter. So in this case, I have O. And then after I find the letter, I'm going to kind of expand my circle or the region of letters around the current letter that I'm going to be looking for. So like the next one would be A. Okay, this doesn't equal A, but then this one equals A. And then again, from here, I can look at the next letter, which is T, and then look for a T that's a nearby letter. Here there's a T, and then yeah, here's the H that completes the word. So yeah, I would basically just do kind of like a depth first search idea, like a greedy. If I see a letter, I'll expand in that direction until I find the word, or until all of the neighbors are not equal to the current letter.
Right.
Yeah, so I guess I'll write down some like pseudocode that kind of describes this idea. Here's a bit slow. So let's call this. So actually, let me first write my main method. So like, let's call this like find words. Okay, that doesn't look good. Let me get normal. Okay, cool. We'll call this method find words. And I guess, so the parameters are just a board and a list of words, right?
Yep.
Cool, yeah, I don't think, okay. And basically, I'm going to treat this as a 2D array. So I need to iterate through my 2D array. So I can do a for I equals 0 all the way to n minus 1. And then for j equals 0, j is less than n minus 1, j plus plus, or I guess n minus 1, j plus plus. I'm going to run some sort of, sorry, my computer is really slow. It's like run some sort of depth first search, which should return like true or false, I guess, if the word exists in the board. So there should be a Boolean, and if this word exists in my board, then I'm going to, like add the word to my output. Yeah, and then I think at the end I can just return my output list. So yeah, I guess this is the main method that I'm going to run, and then let's go to a new page. Now I'm going to build my depth first search. This is going to be, I guess, more substance.
Wait, before that, does everyone here in the call know what depth first search is? If you'd like. Let's see.
Some do. I think we learned it in data structures.
Well, I can't tell because nobody's answering. But,
yeah.
I can answer. I'm new to CS, so I haven't learned it yet because I'm in data structures right now.
We can do, I guess I could give a really quick rundown. So I guess with graphs and even with trees, I guess you'll learn two main like searching algorithms. One is breadth first search and one is depth first search. With breadth first search, it's level by level. So like, do you know what a tree is, Wanyan? Yeah, so like with the tree, there's like a node and that has a left child and a right child. And then like those nodes have left child and right child. Breadth first search is basically going level by level. So it's going, you know, taking the first node and then like taking the children and then like the children of those children level by level. Whereas depth first search is kind of like a greedy search. So it just goes down one path. So like from the root to like one path. Yeah, with breadth first search, you can use like a linklet, like a queue, I guess. And depth first search, you use a stack to implement it. But the same concept applies with the graph. So with the graph, depth first search is really just going like layer by layer, like starting here and then going like to this layer, right? And then like this layer, like, and then like this layer. Whereas depth first search would be like going like down one path, I guess, if that makes sense.
Yeah, that makes sense. Thanks.
What is the space and time complexity of depth first search and breadth first search?
Yeah, so they're both O of n, I believe, right?
Yeah, so it depends though, because I think what you want here is not actually depth first search, right? You actually want some like modified version of it where you can actually, I think for yours, you're actually you're okay with visiting a node twice, if that makes sense. Not like for the same word, but like let's say for your algorithm, because your algorithm's not actually using truly depth first search.
Right.
It's like going like in one direction, and then if it doesn't work out that way, you're gonna redo it, and you could end up revisiting that node, right?
Mm-hmm.
So in your algorithm, it's not actually depth first search, but the real depth first search, it would be linear in the input, and that's the reason behind that. Honestly, like the way I'd explain it is like DFS, BFS, it doesn't matter. Like either one works. The thing that you guys should be concerned about when you think about these algorithms is like it's just a way to enumerate through all of the different input. Like for this example on the board, it's just a way for you to visit everything on the board. Whether you do it depth first or breadth first in this problem doesn't really matter.
Right.
There's like some like average case might be better to actually use depth here, but in this one you don't actually need depth first search, or you're not actually going to use it, right? Because you're not going to like have a visited set, and you're going to have when you like traverse for that word, but then once you propagate back up, you're like resetting the board, right? So like it's like a modified version of it, I guess. So.
Yeah, I think this is more of like a flood flow algorithm. I don't know if anyone knows that, but flood flow basically just checks the neighbors of a node. So yeah, I mean, it might be easier just to show it, I guess. What do you think?
Yeah, just implement the thing.
Sure.
I would call it like something rather like DFS itself. Sure. Yeah.
We'll call it like outwards trav or something. Yeah, because my computer is really slow when it's sharing screen. Okay. Okay, cool. So this is going to be my helper function. I guess the first parameter it needs is obviously the board and the words array.
How about I share screen and you can just type? Is that okay?
Okay, sure. Yeah, that works. Let me make you a co-host then. Oh, also, Oh, you got it. Yeah, cool. So I'm also gonna make someone else a co-host to let people in, because here, Wanya, I'll make you a co-host, okay? Just if you see people in the waiting room. Thanks. Cool, so I have my board, my single word, I guess, that I'm going to, try to find in the board. I'm going to need an X coordinate and a Y coordinate that corresponds to, the location where I start my search. So if you go back up to the board with oath, you see, if you scroll up a bit in the board, you see like oath, that's the first letter of my word that I want to look at. So I'm going to stop there and then do my depth first search, or not depth first search, but like traversal. So that would be like index 0, 0. And yeah, let me see what else I need to do. Okay, so I'm going to have a counter variable that just like tells me the length of the current word that I've found so far in my traversal. So basically, I'm going to do this recursively, where I visit like x plus 1, y plus 1, or sorry, x plus 1, y, x minus 1, x minus 1, y, and then like x, y plus 1, x, y minus 1, because that corresponds to like the left, right, up, down neighbors of my current letter that I'm on. So since I'm doing this recursively, I need to come up with a base case. So when would I return true? Okay, so I return true if my counter equals the length of my word, because I'm going to increment counter at every iteration of this search. So the next iteration counter would equal 1 because I've reached and approved of one letter that matches with the letter in my word. And then I guess with the false case, I'll write that later. For now, I'm going to just write my recursive relationship, which is basically, yeah, just I'm going to return this function with my current board, my current word, again, x plus 1 to correspond to the letter that's below my current letter, y, and then counter plus 1. Since it's a Boolean, if any of these are true, I know that I will be able to, gosh, this indexing. If any of these are true, then I know that the word exists. So I'm going to go down, up, left, or sorry, right, and then left with this depth first search. So yeah, I think this is kind of like an outline of what I wanted to do. Now I need a case where I return false. Okay, so the first thing I notice is if I'm on oath, the index of the letter O is at 0, 0 of the board. So that means that, the x minus 1 and y minus 1 cases will give me an index out of bounds. So I guess to prevent that, I can just real quickly do some sort of checker. So if x is outside of, if x is outside of my board's index, or if y is outside of my board's index, then I can return false. Another time I return false is if the current letter that I am on does not match with the letter in the box, so like the neighboring box. So like if we go back up to the board, if we have the word oath, could you scroll up to the board? Yeah, so like with the word oath, we first start with the letter O, but then let's say we go down to the E. This E does not match the A that is in the word oath. So we can stop our, like search at that, like right there. So basically if board of XY does not equal the letter at my counter, then I can also return false. So this is, I guess this counter variable kind of just helps with both my base cases, because if the counter is equal to the length of my word, then that means that I've traversed or I've run the recursive call counter many times. Otherwise, if the letter does not match, then I can return false. And what's really nice is that since our function is a Boolean, returns a Boolean, we can return true if any one of these returns true. So yeah, I mean, does this seem like it's on the right track?
Yeah, I guess I would say, I think we could cut it there. I think we don't need to fill in all the details.
Okay.
Yeah. So I guess my question here would be, so you mentioned, I guess, do you think there's any way to improve this algorithm? Like, I guess, what are some, is this the fastest way, or are there any other ways to make it faster or better?
Yeah, so back to what I was saying in the beginning, maybe using like a prefix tree. So we could record all the prefixes that might appear more than once.
Right. What about outside of that, though? Like, just for, let's say you want to have the same logic, but, maybe, is there any things that you could tweak? I guess, what are some issues that you can run into with an algorithm like this?
Yeah, sure. So I guess one of the things that I was thinking about is with this algorithm, I'll need to like temporarily delete a letter on the board. Because basically it's possible that with this algorithm, it swaps like back and forth. So like if the word is like an, and I have an A and an N next to each other, it'll take the A, go to the N, and then from the N, it'll go back to the A. So I don't have like a way to, memorize the nodes that have been visited yet. So the way I would solve that is by, deleting the letter after I, I've like looked at it. And then I have to like put it back after I run my recursive functions. And I know that like, it's really bad to modify, I guess, the input.
What about outside of that?
Outside of that,
is there anything weird about this here?
Right. Yeah.
Like, let's say my board has 100,000 by 100,000. Like, and there's enough memory for the board to fit, and so like memory isn't a huge issue. But is there any issue with this?
I guess since I'm doing this for each word in my list, I'll have to run like my double for loop going through the board each time I go through a word, and then for each word I have to, in the worst case, I'll traverse through the entire board, I guess, if that's what you're.
Does anyone else want to take a stab at it? So the question I'm asking is like, let's say I have a board that's 100K by 100K, and I run this algorithm. There's enough memory, but I don't know, is there any other issues that anyone here could foresee?
Would it run for a very long time? Is that a possibility? Like if it's not a memory issue, it's a time issue?
No. Anyone else want to take a stab at it?
I think you said there's enough memory, but is it the fact that you're passing the board in multiple times?
Now, let's say the board is being passed by reference. So you're only passing in like an integer representing the address. I'll just say it, but good guesses. So the thing is, you implemented your traversal as a recursive operation. I don't know if you guys have heard of Stack Overflow.
Yeah.
There's a website, right? But there's an actual thing called Stack Overflow, where your programs cannot just continuously add calls, right? If you have for example, for your thing, if I give you a 100K board and 100,000 or like a million character word, right? Your thing would just crash because it would Stack Overflow, because there'd be a million calls, right? To functions. So yeah, naturally, that's why people would, I would say, almost never write recursive functions in industry. So I'm curious, like, given that, is there a way around this?
A way around the
recursive function. You don't have to modify your algorithm. The algorithm itself is, let's say that's fine. Is there a way to modify your implementation such that it doesn't run into this issue? You don't have to code anything. You just have to tell me.
I guess then probably with like going back to the idea of like a DFS. Although that would wouldn't that also that would also be recursive, right? So
could it be that you can implement a queue? So like instead of using recursion, use a queue to do DFS?
Yeah, so that would be formally called the iterative way to implement this. And yeah, that was the thing I was looking for.
Okay.
So yeah, maybe we could cut the tech interview here. I think you got the outline. I don't really care about the whatever small little things here. I would say I've had interviewers cut the interviews, it's fine, you don't have to fill in all the details. But it would be obviously a bonus. Do you want me to give you feedback, or you want me to just send it to you privately? Or
oh yeah, no, you can give me feedback now. I think that was good to show people.
Okay. Yeah, so I think Eddie, he didn't do bad. There are a few things though. So let me actually I can keep the screen share. So I wrote down a few things that I was just kind of pointing out that it's more of a personal preference. Some of them aren't. Some of them are objective. So this is a small thing, but in the beginning, I know we actually already solved this question before, so it's not like he was actually thinking about the solution. You already had the solution. But when you do go into an interview, there are two things in the beginning. So definitely ask your interviewer before you start coding. So I think you kind of went into it and you were like, oh, there's a try thing, but I can't implement that. So I have this other way using DFS, right? And then you kind of just went off and coded. I would say do not do that because you're not even sure if the interviewer likes your solution or not, right? And you kind of want to me, when someone would do that, it seems like you kind of lack communication skills, not in a mean way. It's just oh, you're kind of just off in your own world. We're supposed to be working together on this problem, but you didn't even ask me oh, do you like my solution? Or is that a suitable solution? So I highly recommend making sure and being on the same page with the interviewer, and always treat interviews as you're working together to solve a problem, okay? So that was the first thing I noticed. I was like, whoa, you didn't ask me if I was okay with the solution or not.
Yeah, sorry, I assumed that we were, but.
Yeah, the other thing is on the tries thing, I know you mentioned that you don't know how to implement it, but I would never mention it like that. And I would typically get to the point where it's you typically have a solution, and then after you code it, you have a different way to do it. You wouldn't want to go I have this better solution, but I can't code it. That's a pretty bad way to get on the in the beginning with an interviewer. And I would, as an interviewer, I would maybe even prefer to see that you can code a little bit and actually get to the optimal solution than you to get a complete working solution with the the non-optimal way. This is a more pedantic, but I think the code could have also been a lot neater. I don't know if that is not very concrete, but I think the code cleanliness is something that might tip you over the edge. Obviously, it depends on the company, but if I was the interviewer, I would definitely notice oh, that's not as clean. You have Boolean here, but then this one doesn't have a tag.
Yeah.
Type. So I try to be very consistent. You're also kind of showing the interviewer that you can code, and I would say that matters a bit. Obviously, don't know for how much it matters for everybody, but if I was the interviewer, I would care a bit about it. So you wouldn't want to go start here, have no types here, and then all of a sudden you have this. It just throws me off a little bit. Kind of it shows that if you just kind of stick to one format, and definitely think a little bit more on code cleanliness. I think that is pretty important. The other thing is, I think the way you explain your thought process, it could be a little bit more concise, and I think it would definitely be beneficial for you to think about how to formalize your explanations a bit, because I think when you're explaining things, you kind of go off on examples like, oh, if A is here and N is here and like whatnot. I would say that's, imagine on the other side, it's kind of hard to follow, I guess. So I would try to be a little bit more formal in your explanations. Obviously not to the point where you're like, given this situation, if that, like, but I would say like, just don't like, maybe you can give examples, but always kind of preface like, oh, as an example, but it shouldn't be that the example is the only way for you to explain this thought process. So yeah, I guess the explanation part would threw me off a little bit too. And yeah, but yeah, I would say and then overall, just like try to be more kind of interactive with the interviewer. It's not like a monologue, I guess. It's a kind of, at least for me, my style is always to have a bit more dialogue with the interviewer. But yeah, I think if you can polish up your coding a little bit more and maybe do more practice interviews, it won't be too bad. So yeah, I will stop screen sharing, but I will say for this question, there is a more efficient way to do it. And I don't want to spend too much time. I'll just say like for this one, the problem is like there's multiple words, and any solution works fine if it was just one word, but there's multiple words. And so you're kind of doing repeat computation every time. And so there's a neater way to make it so that you do some pre-processing on the inputs. You make it so that it's a better data structure, and so that all the words kind of, you can figure out the answer really quickly. And that is by doing a try. You guys can look it up later. It's pretty important for you guys to know that data structure. So it'll come up for sure in interviews, at some point at least. Maybe not your first internship interviews, but at least in full-time or some point, you at least should know what that is. Cool. Yeah, hopefully that was helpful. If you guys have any questions, I'm here. But otherwise, hopefully that was insightful. And yeah, thanks to Eddie for hosting this.
Yeah.
Yeah, can you kind of expand what you mean by like trying to solve the problem with your interviewer, I guess, like you were saying?
Yeah, so there's a difference between like you kind of going off and being like, oh, here's the problem. Oh, I think it's this, okay, I'm gonna start coding. And yeah, I think this is like the, and you're just kind of talking to yourself. On the other hand, what I would do is I would, obviously you need time to think, maybe like 5 minutes, maybe 10 minutes max about the problem, but you really shouldn't like stay quiet during the interview. I think the awkward silence is definitely there. So yeah, I mean, this is small things. You can make jokes while you're coding or like, but then it's really important before you actually start coding that you clarify with the interviewer, like what they're looking for. Like, do you think this is a suitable solution? It's the things I mentioned before. It kind of all built on my comments about being more interactive with the interviewer. I feel like if it gets to the point where the interviewer is not talking at all and just like watching you, it's like, it probably could work. I'm just thinking like, if you want to do even better, it'd be interesting to try to get them to engage a bit more. So yeah. But I mean, it's not like you have to talk to them the entire time and multitask. It's just like, don't get it where they're like staring at you for 40 minutes and, I don't know how to explain it, but yeah, I don't know if that helped, but just imagine as an example in the beginning where he didn't really ask me if I was okay with the solution and whatever.
Anyone else have anything? This is a pretty valuable resource. So whatever question you guys have. Yeah.
What do you think is like the best thing Andy did?
The best thing he did? I like that he did the pseudocode. I do that too. I think you should always try to do that in terms of get an outline first. Some people try to do the like helper functions first, and it's the worst case where you end the interview and you haven't really finished the entire solution yet. It's better if you have an outline and then the interviewer knows that, oh, if you had more time, you could finish it. So I think the pseudocode thing was a good idea.
Could you, I guess this is like a typical question for SWE, but do you have any experience interviewing for like data science roles? Like, is this very similar to what data science technical interviews are like, or no?
Not at all. I don't have any experience. science, but there's nothing like that.
So
One second, actually.
another quick question for you. Oh, okay.
Or did he say he had to go for something?
Wait, sorry. Okay, yeah.
Oh, okay.
You like are gone. Like we can't see you anymore.
Oh yeah, that's fine. Sorry. Yeah, what was your question?
Oh, yeah. So what I was going to ask was, when it comes to like the difficulty of problems, would this be a fair difficulty of problems that you might get in an actual SWE interview, or no?
Definitely depends on the company and what role you're applying for. But yeah, I would say this is pretty. I would think I would see this problem pretty often. Yeah.
Would that be for a full-time role or like an internship? Or are you talking about an internship, Amelia?
I wouldn't be surprised if I saw this in an internship interview. No, it's not like a. It's like a. I think it's labeled as a hard problem, but it's not like a really hard problem to solve. So I think it's pretty reasonable. And some interviews you might get like 2 of these kinds of questions. So.
Sorry, you can go first.
No, please go ahead, Hunter.
Oh, I was just gonna ask, like, as someone that's new to CS, do you have any resources that you recommend so that I could like catch up on or like learn before going into class or interviews?
Yeah, I mean, I think the classroom is really good for learning, but if you're really passionate, there's tons of books out there. I would say that depends on how hardcore you are, but there's this really good book called Introduction to Algorithms by the abbreviation, and people also call it CLRS. That book's pretty comprehensive, but I think if you're just trying to get your feet wet and like experience computer science, just like try out side projects for fun, or you could also watch lectures from other universities. So yeah.
Thank you.
Yeah, there's also the classics like cracking the coding interview and Leetcode.
Yeah, I just wonder if that like will really fuel your passion for CS. It's like
That's true.
Yeah. I have time for one last question. So if there's anything, or if not, we're good.
It's like, do you have any like general tips for like the internship seasons and stuff, I guess, like for trying to find like an internship?
Sure. Apply now, or apply yesterday, and apply everywhere. And the reason I say that is because the actual like performance on the interviews matters, honestly, not as much as you would think. Sure, you want to get to a certain bar, but everyone gets the same offer at the end of the day. So I think it matters more to just get an interview. I will say, like, for me, like literally every internship I did was like, I did internships. I got offers from normal processes, but every internship I ended up taking was from just like me reaching out to people. So there have also been times where I got rejected from the company, and then I emailed them and they ended up accepting me later. So I'll say just like the persistence matters a lot, especially if you're not some like code genius coming in. And this is kind of a harsh mentality, but I'll say, like, if you, like, the way I saw it as like when I came to university is like, if I don't get an offer, it's probably not that I'm not good enough. It's just that I'm not trying hard enough to like apply. Because yeah, I would say that there are plenty of companies. As long as you're not looking only in SF, only in Seattle, you have to realize tech is pretty big. There's companies in like Florida. There's companies in Colorado. Like I would say if you don't get an offer, it's probably because you just didn't apply enough. So that's my biggest tip for people that are actually applying. Like, don't look just in one area. Look around, especially if you don't have that many options. You 100% can find something. So. Cool. Sorry, I actually have to go, but if you guys have any other questions, I will put my email here, and you can email me. Hopefully this was helpful, and thanks to Eddie again for hosting this workshop.
Yeah, of course. Thanks for coming.
Cool. So I'm gonna take my leave, but I'll leave my email here, and oh, that's the problem. Hold on, I'm trying to copy paste this. Oh, it doesn't copy.
I can, the disguised one, I can send them.
Yeah, there, and I'll see you guys later.
All right.
Bye.
See ya. Cool. Yeah. Thanks for coming, guys.
What is that email? Distinguished Sweet.
Disguise Sweet. He wants to remain anonymous.
Oh, okay.
Yeah. But yeah, again, with what he said at the end, I feel like that was really good. There's a lot of like great platforms where you can apply to different companies. So I know Jumpstart's one that a lot of companies are using right now, and it's really easy. You just have to update your profile, and you can quick apply to like 10 companies a day. That's what I've been doing, and like that's what a lot of other people are doing. And yeah, just reach out to people on LinkedIn, like like connect with recruiters and like ask them, about like the role, I guess. Obviously do some research beforehand, but yeah, just be proactive, I guess, in your job search. Do you guys have any last minute questions that I could potentially answer? I don't know. Like,
Facebook?
what's up?
Did you intern at Facebook?
No, Ryan did. Yeah.
Ryan, the interviewer.
What's up? You're kind of
Ryan,
cutting
the
off.
interviewer?
Yeah, the Google guy.
Okay.
Disguised Sweet. Yeah,
Okay.
I would definitely recommend to reach out to him too. Like if you have any other questions or like if you just want to talk about like random projects or whatever. He's also pretty good with like referrals too, I think. I don't know. But he
At
said like
Google?
last time. Yeah, to people. Just like introduce like yourself, send them your resume maybe, and he'll ask you like about a project or something that you're passionate about. And maybe he'll refer you.
Okay.
I know on LinkedIn he did offer to refer like full-time people, but I'm sure maybe it'll be the same for interns. Yeah.
Okay, that makes sense.
Yeah, of course.
Eddie, how did you meet Ryan?
We went to this. He did a similar event that I went to, so I was one of you guys, and I just reached out. Yeah.
Love it.
Cool. Yeah, but I'm gonna end the recording now if no one else has any questions or anything.
Thank you, Eddie, for